Hi guys, this is factoring special cases, perfect square, trinomial. So we're still on factoring special cases, but this is the second type of special case. So again, we had this one back when we were multiplying. So we would have had something like, this is just an example, if I had something like that, and then I wanted to multiply it out, I could write it like that, right? Because squared just means I'm multiplying it by itself. And then I would have to have to FOIL it out. So x times x is x squared. 1 times x is x. Okay. X times 1 is x. 1 times x is x. 1 times 1 is 1. And we ended up with a pattern here, so you could simplify this. You'd get x squared plus 2x plus 1. And so we noticed a pattern when we were doing it in this direction, right? We said it would just be the first thing squared plus 2 times the first thing plus the second thing plus the second thing squared. And that was if I had a plus b squared. So in that first video, we went this direction, right? In this video, we're going to go this direction. So if I have something of this form, I can factor it, and it's going to look like this. So I have the first thing squared plus 2 times the first thing times the second thing plus the second thing squared. If I have this pattern, then I can factor it as first thing plus second thing all squared. So let's look at that in terms of actual numbers. So let's do some erasing here. And so let's look at number 10. So for number 10, I have 25 is 5 squared, right? And r obviously is r squared is r squared. So if this follows this pattern, my first thing would be 5r, right? I'm just taking the square root of the first thing. And then my second thing would just be 1, because the square root of 1 is 1. So we're taking the square root of the first thing and the square root of the second thing. But then to actually make sure that this does follow that pattern, because I can't know for sure right now, I have to figure out if this is 2 times the first thing times the second thing. So I need to check if negative 10r really does equal the first thing times the second thing times 2, right? So I'm going to have 2 times 5r times 1. Well, that's 10r. The only thing I'm missing here is the negative, which means that instead of having a plus in between them, these two need to have a negative in between them, and then this will work. And squared. So this is in fact what's known as a perfect square trinomial, because if I take the square root of this times the square root of this times 2, I get the middle term, assuming of course that the 1 was negative. Okay, so if the middle term is negative, I'm going to have a negative here. If the middle term is positive, then I'm going to have a positive here. So you would think it would be this term, but actually this term is always positive because anything times itself is positive, right? And -1 times -1 is +1. So since this is just this term squared, that's -1 times -1 is +1. So it's actually this sign that I care about. This sign will always be positive. If this sign is not plus, then this is not a perfect square trinomial. The only one that can be negative is the middle. So when I'm doing this, I have to check and make sure that it is in fact a perfect square trinomial. So I take the square root of the first thing, take the square root of the second thing, and then I multiply them together and multiply that by 2 and see if I get the middle thing. And if I just get the negative version, then I need to make, or I get the positive version, it's supposed to be negative, then I just need to make that negative. And it's the one that was negative, so I can just do that. And it's always going to work out if this is negative, this needs to be negative. So let's do another example. I'll take the square root of 9v squared. Square root of 9 is 3. Square root of v is v. Square root of v squared is v. And then I take the square root of the last one, so the square root of 1 is 1. And then I check and see if I multiply these together, multiplied by 2, do I get the middle term? So 2 times 3v times 1. 2 times 3 times 1 is 6. And then v, so yes. So this is in fact the factored form because it follows that pattern. Now, any of these you can factor using any of the factoring methods that we talked about, like AC with grouping and slide and divide, but clearly this is faster, right? I didn't have to figure out factors of 6 or factors of 1 times 9 that add to 6. I didn't have to figure any of that out. So if I can see that this is a perfect square trinomial, it makes the factoring way faster. All right, let's look at this one because this time we have 4 here. Now I've talked about in previous videos how if you have a larger exponent here, we can still factor like normal as long as this is half of this. So half of 4 is 2, so this is fine. So if I can take this and I can say this times 2 gives me this exponent, then I can still factor it, as long as this one doesn't have a variable with it. If this one had a variable, then I would just, if they all had a variable, right, I would just factor out that variable first before I did anything else. Okay, so let's give this a try. Now that doesn't mean, by the way, that everything is factorable. On these worksheets, everything is factorable because that's the point of the worksheet. But that doesn't mean that that's always going to be true. You can have things that are not factorable. So you just have to be careful of that later on down the road when we're using factoring. There'll be situations when that doesn't work, and we can't factor. And we'll talk about that more when we get there. Anyway, so basically when I take the square root of this, I'm just going to end up with 4p squared instead of just 4p. This is how this 4 is going to change it, right? Because when we take the square root of something with an exponent, we can just divide the exponent by 2. So square root of 16 is 4. Square root of p to the 4th is p squared. And then, of course, the square root of 9 is 3, and then I need to check 2 times 4p squared times 3. 2 times 4 is 8. P squared times 3. 8 times 3 is 24. P squared. That is, in fact, the middle term, so this factoring trick does work. So I can just do this, and that is my answer. So that's how this works. Again, if you have a minus, then you're going to have a minus here. So bear that in mind. So for example, this one would be 5b squared minus 2 instead of plus 2. Minus 2. So that would be the answer here, the minus, because this is a minus. And 5 times 2 times 2 is, so 5 times 2 is 10, times 2 is 20, so this is what you would get. All right, so hopefully that helps, and I will see you guys in the next video. Let me know if you have any questions.